Hey everyone! Today we're diving into an absolutely epic cosmic journey. We're going to trace the 4.6 billion year story of how our own planet was built. I mean, from just a chaotic cloud of dust to the world we call home. So yeah, let's get right into it.
So really, think about it. How do you build a planet completely from scratch? That's the big question we're tackling. We're going to frame this whole thing like a cosmic construction project, putting our world together piece by incredible, chaotic piece.
All right, so here's the game plan. First up, a cloud of dust. Then, we'll see how worlds are made from tiny grains. After that, a planet forged by intense heat, followed by a huge cosmic impact. Then, our world takes shape, and finally, the first signs of life. Let's do this.
Okay, let's kick things off with Phase 1, a cloud of dust. This is literally the blueprint for our entire solar system. To really get this story, you've got to wrap your head around the timeline. We're going back, way, way back, 4.6 billion years ago. The scale is it's mind-boggling. And this is where it all begins.
So this was the starting point. Everything you see in our solar system, Earth, Mars, Jupiter, all of it, started as this single, massive spinning cloud of gas and dust. It's called the solar nebula. It's kind of like the giant cosmic quarry where all the raw materials came from.
All right, on to Phase 2. This is where we see how all those raw materials start coming together. We're calling it worlds from tiny grains. Think of it like a cosmic assembly line, and the process has a name: accretion.
So how does this even work? Well, the best way to picture it is like a snowball rolling downhill, getting bigger and bigger. Tiny little dust particles in that giant cloud started clumping together. Gravity, static electricity, you name it. These clumps grew into bigger bodies, some kilometers wide, called planetesimals. And then, for millions of years, it was just chaos. These things smashed into each other, over and over, building up into a protoplanet, basically baby Earth.
And all that smashing together brings us to a really crucial stage, a planet forged by heat. See, as this baby planet got bigger, the temperature just started to, well, skyrocket. And we're not talking about a little bit of heat here. This was a full-on planetary furnace, and it was powered by three main things. First, you've got the constant energy from all those collisions. Then, you have heat coming from radioactive elements decaying deep inside. And finally, just the immense pressure of its own gravity, squeezing everything tighter and tighter.
All that heat literally melted the entire planet. It went from being just a jumbled-up ball of rock and metal to this glowing, molten sphere. And when that happened, something amazing occurred. The super heavy stuff, like iron and nickel, sink right down to the middle to form the core. And all the lighter materials, they floated to the top, creating the mantle and eventually the crust. That whole process is called differentiation, and it's why our planet has the layers it does today.
But you know, just when it seemed like our planet was really starting to take shape, the universe threw a massive curveball. This is Phase 4, the Great Cosmic Impact. It was basically a giant demolition and remodel that changed everything.
Seriously, try to picture this. An object the size of Mars slams right into our young Earth. This wasn't just a fender bender. It was a cosmic cataclysm. It nearly destroyed our world completely. It's just a wild reminder of how violent and chaotic the early solar system really was.
But out of all that insane chaos came something pretty incredible. The huge cloud of debris that got blasted into orbit, it eventually clumped together to form our moon. It's just amazing to think that this catastrophic collision is the exact reason we have a moon in our sky tonight.
Okay, so after that giant impact, it was finally time for the, let's call them, finishing touches. This is Phase 5, where we get to see how our world finally started to cool down and really take the shape we know.
So this is basically the planet's recovery phase. First, the molten surface finally cools down enough for a solid crust to form. Then, volcanoes everywhere start erupting, just spewing out gases and creating our first really early atmosphere. Now, that atmosphere was packed with water vapor, which condensed and started to rain. And it didn't just rain for a weekend, it rained for millions of years. And that's what formed our first oceans.
You have to understand, this early Earth would have been totally alien to us. Completely unrecognizable. The atmosphere was super thick with water vapor, carbon dioxide, and nitrogen. But look what's missing. The crucial part: no oxygen, none. Taking a single breath would have been completely impossible.
And that brings us to the final, and maybe the most incredible phase of this whole construction project, the first signs of life. The planet was finally ready for occupancy.
Now, life didn't just show up with a big bang. It was much, much quieter than that. It started really humbly, just simple chemical compounds swirling around in those brand new oceans. And over millions upon millions of years, these compounds slowly started organizing themselves into the very first super simple life forms.
And here's the ultimate plot twist in our whole story. Some of these tiny early organisms figured out photosynthesis, and they started pumping a waste product out into the atmosphere. What was that waste product? Oxygen. This was the Great Transformation. These tiny little microbes started terraforming an entire planet, completely changing the atmosphere and paving the way for all the complex life that would come later, including, well, us.
So, what's the big takeaway here? Earth's story, it's not some neat, tidy blueprint. It's this breathtaking, messy story of chance encounters, unbelievable violence, and radical transformation. And it really leaves you with a huge question, doesn't it? If this is the incredible, and let's be honest, improbable journey it took to build just one world with life on it, what does that really mean for the chances of finding life anywhere else out there in the universe?